Hello everyone, I am Snigdha Kakkad and this is my channel AccelerateAICareers. Today I have brought a very interesting problem, LeetCode 227, Basic Calculator 2. It's a series of questions for calculators and this is the second question in that series. It's a medium level complexity question. The companies which have asked it in last 0 to 3 months of interviews are these. Meta has asked it 76 times, Amazon 11 times, Microsoft 4 times. So it's a very famous question. And let's see what's the complexity associated with this question and why is it such a popular question. Even though there is no follow-up mentioned here, the complexity here is that you have to solve this question in O1 space complexity, that is constant space complexity. That is what the solution which your examiner is expecting out of you. Anyone can code ON space complexity question using a stack, but you can't solve this question using a stack. So that's how this question becomes more complex for you. Now, what does this question say? So as a calculator works, you will be given a string expression which has either the digits or mathematical operations or space. Only these three things can be there. And the expression given to you is always valid. All intermediate results are in the range of minus 2 raised to power 31 to 2 raised to power 31 minus 1. You are not allowed to use any built-in functions that give you the results right away. For example, evaluate strings as mathematical expressions such as eval. Let's look at some examples. Like example 1, here 3 plus 2 multiplied by 2. So we always follow BODMAS rules, that is brackets, orders or powers, division, multiplication, addition and subtraction, and we prioritize each sub-expression based on that. So 3 plus 2 multiplied by 2. So multiply takes priority. So 2 multiplied by 2 is 4. 4 plus 3 is 7. That's your output here. In example 2, there is one space ahead, one space after. You can just skip that space. And 3 integer divided by 2. And they say that the integer division should truncate towards 0. So 3 divided by 2 gives you 1. Even though it's 1.5, but since it's integer division, the output would be 1. Now, the third example is 3 plus 5 divided by 2. Division takes priority. So, 5 divided by 2, integer value would be 2. And 3 plus 2 would be 5. That's your output here. Now, what's the intuition behind solving this question in ON time complexity and O1 space complexity? So, ON time complexity is pretty clear that you will go through the expression only once. And depends upon the case-by-case basis, you might be rolling over a bit, but you will not go through the whole expression again and again. And the space complexity O of 1, that means you cannot use any additional data structure per se to solve this question. So what's the intuition behind this question? Let's look at some of the examples to solve this question. Here in example 1, I have taken only OR addition operations and no other operations. It's pretty clear you initialize your result as 0. And then you go through left to right in your expression. So it's a simple example here. When you go through left to right in your expression, then 3 plus 5 gives you 8. 8 plus 7 gives you 15. 15 plus 2 gives you 17. And you keep on updating your result and at the end you return your result. So you would say the intuition is pretty clear. You go left to right and then you take in which operation it gives, whether it's addition, subtraction, multiplication or division. And based on that, you update your, but it's even more complex than that. Let's look at another simple example first, where you have addition and subtraction. So you first take 3, and then you see the operation given to you is addition. So 3 plus 5 is 8, and then you again see the next operation is not addition but subtraction. So you update the operation first, and 8 minus 2 is 6. That would be your output. Again, you're going left to right, but at this time, you are also updating your operation here because you are not defaulting the operation as addition every time. Let's look at a complex example. So here, if you start from left to right, you will first add 3 plus 5, 8. And then you would divide by 2, which is 4. But your answer is not 4. Why? Because you should follow BODMAS and you should prioritize division first. You cannot go left to right here. So you first have to do 5 divided by 2, that is integer division, and you'll give 2. And then you have to add 3 and your result would be 5. So you would ask me, then my previous intuition is not working here. Well, it can work, but you have to update a few steps here. You initialize from left, you start, and you first take 3. You add 5, you get 8, but save your prior number here. So you reverse that operation which you just performed. So 8 minus your previous number of 3. So you get 5. Then you do your division first. and 5 divided by 2 will give you integer, division will give you 2, and then you add your price. So basically, you are still going from left to right, but if you come across a mathematical operation that takes more priority, such as a division or a multiplication, in that case, you reverse what you did before. You subtract your prior value from the current answer, and then you first perform the division or multiplication, and then you add that value again. So it would basically be 3 plus 5, 8. But then you realize that the next operation given to you is division, which is higher priority than addition. So you subtract 3. So you have stored 3 somewhere in your previous. 8 minus 3 again 5. Then you divide by 2. You get 2. And then you add your value which you subtracted earlier and you get the answer as 5. Now, similar to that, in complex example 4, you have been given 3 plus 2 multiplied by 2. So you first start from left to right. 3 plus 2 is 5. Multiplied by 2 should give you 10, but that's not your result because you have to follow BODMAS. So you go from left to right. 3 plus 2, 5. But then you see the next operation is multiplication, which is a higher priority operation than addition. So you subtract your stored previous from 5. 5 minus stored previous is 3, 2. So you get 2. You multiplied it by next value, which is 2. 2 multiplied by 2 is 4. And then you add the value which you subtracted earlier, which is 3. So you get 7 here. So basically, I start from left to right 3 plus 2. And then I see if it is multiply or division. I reverse the operation which I just performed, save that value. I perform the division or multiplication and then I add that value. I hope the intuition behind the question is clear to you. I know it's a more complex one and it's not very visual to understand it. So let me code it for you, and once we code it together, you'll be able to understand my approach better. So let's start coding it. First, initialize my pointer, which I will track where I am in the current expression. And that pointer I'll initialize by 0. After that, I will also initialize my current value and previous value as zeros, as well as my result as 0. So after all the initializations have been done, I will also presume that my current operation is plus because my result initially is initialized as 0. So I will add the first value, whatever the first value in the expression is, to that 0. So I will initialize my current operation as plus. Now after that, I will initialize my first loop. So while I is less than length of the string, which is given to me, string is s. So I'll run that while loop. And I will take my current character. So my current character would be s of I because my current pointer is I. And then I will check because my value at any point could be either a space character or a digit or a mathematical operation. So I will first check if my current character is digit. So if it is a digit, then I will go ahead and I will update my current. To update my current, I'll first have to check for two conditions. While I is less than length of s, that is it's not out of bounds, and s of I is digit. So basically that's not a space, it's not a mathematical expression. In such a scenario, I will update my current, and my current would be my previous current multiplied by 10 and plus I will take the integer of s of I. Because currently my s of I is a string, right? So I'll convert it into integer and add that. Now I will increment my I pointer, and this would be my nested while loop. So, but if you say you reach the end of the string, you don't want your I to be surpassing that. For example, if you have 334 plus 34, then if you keep on adding I plus 1 equal to 1, when you have updated your current value with 334, your I pointer will automatically reach this plus pointer value. Because I is plus equal to 1. So you don't want that. You want your I to be at 4 first. And then you want to increment it and take the operation, whatever operation is given to you. You want to reverse that I plus equal to 1 so that it doesn't go out of bounds. So I will do I minus equal to 1 outside the loop so that when the addition gets completed, it's still at the prior digit and it doesn't reach the mathematical operation as of yet. After that, I will use my if condition to check if this current operation is addition. If it is addition, in that case, nothing. I will just add the current value to the result and my result gets updated. If current is subtraction, I will subtract the result, subtract the current value from the result. It won't be if here, it would be else if. Now, else if my current operation is multiplication. In such a scenario, the solution would be more complex because I will have to reverse what I was doing earlier. As we discussed in the example as well, I will first subtract my previous value from the result, which is saved in previous variable. And then I will update my result by adding previous multiplied by current to it. And once I have done the multiplication operation, after doing that, I will update my previous. My previous would be current multiplied by previous. That's it. So if it's a division operation in such a scenario also, I will first reverse the prior operation which I've performed of the addition. I will subtract previous from the result, and then I will update my result, and I will be adding int of previous divided by current. You would ask me, why didn't I do integer division instead rather doing int of previous divided by current? That's because if the value, either previous or current value, is negative and you'd perform integer division there, the round up value which you get is incorrect. So you want the answer to be correct, and that's why you have to perform int function rather than doing an integer division. You can try solving it with both. With that, some of the test cases will fail. And you will update your previous value. Your previous would be int of previous divided by current. So now, once you have done it, you have to reset your current. Every time you have performed the operation, you are going next, and you have already used this current value, you will reset it to 0 again. Once you have reset your current value, after that, I will write else if, because this particular, when I'm checking if current character is digit, this current character could also be not digit. It could be a space, it could be a mathematical operation. So else if this current character is not equal to space, so it's not a digit, but it's also not a space. In such a scenario, it would be a mathematical operation, and I will be updating current operation based on that. So current operation would be my current character, and then I will do I plus 1 for this while loop, while I less than. So I will do I plus equal to 1. Finally, I will return the. So this is my solution, entire solution. I hope it's clear. Let's run it. So there is some mistake here. Let me check. I forgot to update my previous here. So my previous would get set to current, and here my previous would get set to minus current. So initially I updated my result for previous, my values for previous for both multiplication and division operation, but I forgot to update my previous for my addition and subtraction operation, and that's why I was getting a wrong answer. So let's run it. See, it's accepted. Let's submit. So the solution is doing pretty well here. And the time complexity would be O of n, since you're going through the expression only once. The space complexity would be O of 1, that is constant space complexity. I hope the solution is clear for you. If you have any doubts, ask them in the comments here. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.